compression, rarefaction, open it quickly. Then you see the cloud is coming. Till now it is coming. When all the dust particles will go away, then it will come. So it has a limit. I hope everybody can do it. Yeah. Now call Lippy. Lippy will see that all the backbenchers are listening to me. Okay. Very good. Thank you very much. Now, I don't know. No, isothermal like saying, isothermal all of you do because it is boiled. It starts from 8, 9, 10. But aromatic is not been done at 8, 9. Isothermal came all immune. So in 11 you know aromatic. That's why I named the saying, even you know aromatic. If you know isothermal, as you know Now I am going to perform a very old experiment. Very old experiment in your 7-8 book was there that I have a glass and a paper curve. I have a glass and paper. What I shall do, I shall fill it completely with water. Completely or half? Half. Okay, this is half. Some said complete. Half or complete? Some said complete. Okay, let us do complete, then we shall do half. Why I should give any preference to anyone? It is completely filled up, and in our book, even in the NCIT book it is given that after holding this page, you turn it over within the I take a plastic cut because it gets weight. When it gets weight, you can see the shape change. So again I take full, no, half. Full has been done. Now there is a list. A great list. If I release it, will it fall? Unless you do the experiment, oh, your heartbeat has gone to 200. Anyway, now, why it is not fall? I take very small amount. Put it here.
Atmospheric pressure.
Sure. He is giving the answer. But he is wrong. Of course, atmospheric pressure. There is a lot of things to see in. Of course, atmospheric pressure. Say I take a very little water, turn it over, it does not fall. I throw away, it does not fall. So what is happening? There must be some more things here. Acha, let me tell you. You just tell me, if I put this card on this, what is the pressure here? We say air pressure, normal air pressure. What is this? Anybody? Is it less than air pressure? Greater than air pressure? Equal to air pressure? You are convinced that it is equal to the air pressure. If it is air pressure, and that is why the author say if this is air pressure, this is air pressure, then because of this weight, it will fall. Isn't it? If this is air pressure, if this is air pressure, then there is water, so it will fall. Not falling. Then we have to. You see, look at it. I have a very special glass paper. Wonderful. This will tell you the answer. I don't have to explain. I put it here. Turn it over. Now if I remove my finger, why? Don't worry. Now this is a hot scissors. Get some water sprinkler. Now you see that this proves definitely that the air pressure inside is less. Then a problem comes. Then if it is less, then it should go inside. It should be safe. It should be safe. All of you are safe. And you are right. The air pressure within is safe. But when I inverted it, the pressure becomes less. Why? For that, I take a heavy glass cup. Not this light one. Then take this, put it here, reverse it. Now look at the glass cover, is it fixed? But when it is erect, is it moving? No, that because there is some lubrication. Still the lubrication is there. Now it will not, it will moving, but not like this. If you come very close to it, then you will see water level can be seen here. You stand up and look between the glass and the plate. You see the water? Huh? You see the water? Okay, go back. So what has happened? That when I inverse it, everybody can see this. When I reverse it, then the weight of the water pushes the plate slightly down. When it pushes it down, then the level of water from here also goes down. Maybe very small. Then what happens? This air space, the volume of the air becomes more and the pressure less. So that is why now the pressure is not atmospheric, as I have proved by this. That when you open this, air goes in, pressure becomes equalized, so it falls. To extend it further, let me take this one. This is very interesting experiment. How experiments can be done? Because innovation is something you have to do. I don't know whether I can do it because the glass is not large. I have certain coins. It has other uses. I will show you later. It is not attaching properly. But anyway, let me see what happens. I have another plastic cup and a hanger, a James clip opened up so that I can hang something from here. Now I fix it with this card also, this plate. see whether it can take this weight. Let me see. Yes, it can take. Now I take coins. Each coin is 5 grams. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. It holds, it can hold lot of weight. 10 gram slip, 10 coin slip, 50 gram. So I put 50 gram weight here, and still this can hold, and all my coins in this bucket. Yes. So, experiments are wonderful. From experiments you can derive many things. But one thing must be very curious, because if you put more weight, that means the curve what is there, it is gradually coming down. Then it is okay. The air pressure is important. When we have hot water here, this pressure decreases. So if I can insert some air, it will fall. But who is holding this? That is the question. Who is holding this? Let us do another experiment. That is also very, very interesting. I have to raise it. Otherwise, something else. This one. This is a glass plate. This is a glass plate. My wife will definitely tell me what you are tasting in your side. She knows, doesn't say anything. Don't tell me that, see it whether it holds. It will not hold. Now what I am going to do, I am going to put these coins between the glass plate and the glass holding them. That means I am trying to make some space. Say I take this one, I think some water should be there. Because I shall wash each of these coins, then dry it up, then put it here. If you measure the thickness of each coin, it will be 1.5 millimeter. That means that 120 degree apart, I am putting another coin. Another coin at 20. Now the glass plate and the water glass has a separation of 1.5 millimeter. I take 3 more coins and put on the top of each. It's a suspense. There should be music like circus. Now it is 3 millimeter. I don't know what you will do for you. 3 millimeter. I take 3 more coins. Hey, take a seat, take a seat, take a seat. Really, I enjoy to do this. Very much. I enjoy it very much. My friends say at the age of 75 you don't feel weak. Because I am with the young people. And from their side, the way they are looking, I get energy. Isn't it? Now 3, that is 4.5. Some water has come down because there is a space below, so water has to come. Otherwise, we will fill up the space. 4.5. Could I give 3 more?
Yes, sir.
Aja, let me first taste. It must be 4.5. It is going through it. Let me take the refill. Oh, you want the light? Good. Come here. I cannot put more because I know if I put more, it will fall down. Now see, if I put some liquid, What is this all about? Why this has happened? Now, for explaining this, I have to do so I am putting it down. If I bring something which you cannot get, how am I to explain? Please take the seat. I have two children, one boy and girl. When they come back from the school, my children are all married. But when they fight, that whatever juice you will give must be equally shared. So before they come, I started to putting it on the top of it. I take this so I can make it half. So I can make it half on the top of it. All of you know why it has happened. Because you have to remember that all physics, chemistry, biology phenomena depends on atoms. Nothing happens without, everything happens because of atoms and molecules. Whatever property you see. For small kids means if it is 5, 6, 7, I say that I take a drop of water here. The water is sticking to my hand. Now I change it. There is still more. I wipe it. Still there is some water here. Then I say that I take it here. Some is still there. That way I ask them, how long I can go making the water smaller. And you know the answer? Up to the molecule of water. What happens? When I am taking this glass, the water is a round shape. That glass can also do the same thing, this glass. It is not that is very special, you see. This is a normal problem with the mothers and sisters. You know? So, what happens? When the distance between them is less than 10 to the power minus 7 centimeter, the glass atoms molecules holds the water molecule. What is that force? Adhesive force. Adhesive force. That is called adhesive force. And I told you, I have a very expensive instrument here, and it's really expensive. The work can do see, two water streams are coming, but they really love each other. They become one. You cross it, they become two. One, two. This is the force of cohesion between water and water. So that was force of addition. This is force of cohesion. So this isn't it a good instrument? Yes. There are two holes of 3 millimeter apart. So from this we can show that molecules are attracted by molecules. We have read friction. In friction, more than the unevenness of the surface, molecular force is more important. That is why in your syllabus, a question comes, can mu can be greater than 1? You know the expression for friction is F is equal to mu n. N is that this is the weight, this is the weight, this is the surface, and this is the normal reaction. So this force needed is mu time. Normally mu is less than. But if you have a highly polished surface, maybe glass, maybe iron, the coefficient may be 10. Because what happens when there is a surface and you put something here, it touches only a few points, and this point, by force of addition, the force is very large. So friction is partly due to the waviness of the surface and partly due to the molecular force. So molecular force is very, very important. Now we come back to this experiment. Why this 6 millimeter water is holding? Obviously what happened? There is a force of adhesion between this glass and the water, and force of cohesion along this. There is a surface, and there is another surface where there is force of adhesion. So this totally makes what you know is called surface tension. Surface tension is a molecular phenomenon. So because of surface tension, though in that experiment air pressure is the main thing. If the air pressure gets reduced, then it will hold. But if the air pressure is increased, it will fall. But when the reduced pressure is holding it, there is a thin layer of water. Due to surface tension, it is holding. So we go back to those experiments. There are other things to discuss. Air pressure is a very important aspect. This is another experiment, all of you know. There is a candle. There is 3 candles. I am going to pour some water here. Then light the candle and put glass on the top of it. Then what will happen, you know, all of you know. These are the two glasses of equal size. Do they contain different amounts of air? Since they are of same size, this air is equal to this air. Now if the volume of air is equal, then amount of oxygen is also equal. So when I put some liquid here, and light the candle, then place it, what will happen? Why water will go? Air will not burn. Yes.